All right, for today's lesson, we'll be using letters to represent numbers. So we'll be doing some algebraic expressions today. And our standards that we will be working with are 6EE2A, 6EE2B, and finally 6EE6 will be our standards that we focus on in today's lesson. So before we start with today's lesson, it will be important to know the difference between an expression and an equation, as well as what's the difference between when it's numeric and when it's algebraic. So if it's numeric, it uses numbers. There won't be any variables, there'll just be certain numbers. So an example of a numeric expression would be 63 divided by 9. 8 times 6, 11 minus 5, 8 plus 4. Those would all be examples of numeric expressions. An example of a numeric equation would be 8 plus 4 equals 12. 9 minus 3 equals 6. 7 times 5 equals 35. 75 divided by 5 equals 15. Those would all be examples of numeric equations. The difference that you'll notice between an expression and an equation is that an equation will have an equal sign and an answer, where an expression does not. To be algebraic, it must use at least one variable. A variable is a lowercase letter of the alphabet that we use to stand in place of a number. One letter of the alphabet that we tend not to use for a variable is the letter O, and we don't use O because it could look like a 0. Another letter of the alphabet that we have to be careful with if we use it as a variable is the letter L. And usually if we use L as a variable, we use the cursive version of the L. That way it doesn't look like a 1. Excuse me. So an example of an algebraic expression would be n minus 14. 12 plus c. 8 times w. K divided by 4. Those would all be examples of algebraic expressions. And an algebraic equation example would be L times 5 equals 40. And you'll notice for multiplication that we use a dot. That's called our multiplication dot. You still say times when you put it in, but we start using the multiplication dot instead of the multiplication x because x is a very popular variable. So our focus today is just on writing the expression. We're not really solving or evaluating anything. We're just writing the expression. So if Anna has 3 apples and she gets 1 more apple, how many apples does she have now? Well, she has the 3 apples and she gets 1 more. So we have 3 plus 1. Or we could write 1 plus 3 because the order does not matter in addition. Well, if she gets 4 more apples, well, she has 3. And she gets 4 more. We can say 3 plus 4. Or we could say 4 plus 3. Her friend gives her some apples. Well, we don't know how many apples. Excuse me. We don't know how many apples her friend gives her. So we have an unknown, which is where we come up with the variable. So we don't know how many apples does she have now. Well, we know she has 3 apples. So she's going to get some more. And we're going to assign a variable here. So we can use A, we can use B, we can use any letter of the alphabet that we want. And again, since it's addition, you can switch the order and everything stays the same. So you could have A plus 3. So if we want to add 0 to 6, we have 0 plus 6 or 6 plus 0, either one's fine. If we add 0 to x, 0 plus x or x plus 0. The sum of 11 and 3, so that'd be 11 plus 3, or 3 plus 11. The sum of n and 3 would be n plus 3, or 3 plus n, because sum tells you to add. It's the result of a multiplication of an addition problem. And then 4 more than 8 would be 4 plus 8, or you guessed it, 8 plus 4. And then 4 more than y would be 4 plus y, or y plus 4. Either of those is fine. Excuse me. So Mr. Garcia is a mathematics teacher. His students do not know his age. Let Mr. Garcia be x years old now. Find Mr. Garcia's age in terms of x. So we don't know Mr. Garcia's age, so we say that he's x years old. So 3 years from now, we know he's going to be x plus 3. Or if you put 3 plus x, same thing. 5 years from now, he would be x plus 5. Or yes, you could put 5 plus x. And 10 years from now, you'd be x plus 10. Or again, you could put 10 plus x. If we add 6 to y, we have 6 plus y, or you have y plus 6. Either one of those is fine. The sum of z and 8, z plus 8, or 8 plus c. 3 more than p, 3 plus p, or p plus 3. And then q more than 10 would be excuse me, q plus 10, or 10 plus q. Well, usually after we work with addition, we then go to subtraction. Now, subtraction, you do have to be careful because in subtraction, the order does matter. So you will not have two options like you do with addition. You'll have to make sure you pick the right option, because if you flip the numbers around, it actually will give you a different answer, which will make it incorrect. So we know that Paige has 5 granola bars. How many more granola bars does Paige have than Kyle? So we take Paige's and subtract Kyle. So 20 minus 5. Kyle has 12 granola bars. How many more granola bars does Paige have than Kyle? So we take Paige's and we subtract Kyle's. And then Kyle has Y granola bars. How many more granola bars does Paige have than Kyle? Same idea here. We're going to do 20 minus Y. Now in this situation and the previous ones, we do have to use the variable that we are given. So since it is defined that our variable here is y, we must use y in our expression. In the earlier example, when we were given just some apples, the variable wasn't defined, so we could choose our own. But if you're given a specific variable to use, you must use that variable. So if we want to subtract 3 from 7, we have to be very careful with how we do this. And when we subtract 3 from 7, it's actually going to be 7 minus 3, because we have to subtract 3. Subtract 3 from a, so it's the same situation, but instead of a 7, we have an a. So we're going to do a minus 3. We have to subtract 3. We want 1 less than 12. So we're going to do 12 minus 1, because we want to take 1 away, because we want 1 less than that. And then 1 less than x, same idea. So we're going to do x minus 1. So Mr. Lee is a new teacher at Central School. The students do not know his age. Let Mr. Lee be k years old now. Find Mr. Lee's age in terms of k. Well, 1 year ago, we would take Mr. Lee's age and subtract 1. 2 years ago, we would take Mr. Lee's age and subtract 2. And 15 years ago, take Mr. Lee's age and subtract 15. Excuse me. So we want to subtract 7 from z, which means we start with z so that we can subtract 7. Subtract b from 8, so we start with 8 and we subtract b. We want 10 less than h, so we start with h, and we want 10 less, so we have to subtract 10. And we want w less than 20, so we start with 20, and we subtract w. As we move on through our operations, usually after subtraction, we begin working with multiplication. So Chica has 2 empty boxes. She puts 12 books in each box. How many books are there in all? Well, she has the 2 empty boxes. We're going to multiply that by 12. In multiplication, the order does not matter, so we could switch this around. And since it's numeric, if you want, it is okay to use your multiplication x. But one thing to remind you of, make sure that's the multiplication x and make sure that it doesn't look like the variable x, which means we have it kind of smaller and kind of floating in the middle there, just like our multiplication dot. But you do want to start using that multiplication dot in your work. She puts n books into each box. How many books are there in all? Well, she has those 2 empty boxes times the n books. Or you could switch those around, n times 2. Or we do have a third option when we have an algebraic expression, and we can write it as 2n. Now 2n does mean 2 times n, and we can only do this when it's algebraic, and when you write it, the number must go first. Excuse me. So Malik has n baskets. He puts 2 eggs in each basket. How many eggs are there in all? Well, as our young lady says, it is n times 2, or we could put 2n. He puts 1 egg in each basket. How many eggs are there in all? Well, that would be n times 1, or 1 times n, as it says there from our young lady. So what we would actually do for this one, we would just put n. If you write 1n, that's okay. I'm not going to mark it wrong, and I'm not going to count it against you. However, we usually don't write 1n because when we multiply by 1, the value doesn't change, so we just leave it as n. So we're going to multiply 1 by 4. So we could have 1 times 4 or 4 times 1. Now, since it's numeric, we would leave it like that. We wouldn't just write down 4 since we're multiplying by 1. However, with multiply 1 by y, I would take 1 times y. I would take y times 1. I would take 1y, or I would just take y. For 6 groups of 10, it's either 6 times 10 or 10 times 6. For 6 groups of k, 6 times k, k times 6, or 6k. Any of those would be acceptable. The product of 5 and 7. So 5 times 7, or 7 times 5. And again, you could use the multiplication x instead of the dot when it's numeric. The product of 5 and h is going to be the same idea. 5 times h times 5, or 5h. So if there are n stickers in a pack, find the number of stickers in terms of n. Well, if there's 1 pack, there'd be n stickers. If there are 3 packs, it would be n times 3. If there are 6 packs, it would be 6 times n. 10 packs would be 10 times n. And 15 packs would be n times 15. So all those are acceptable ways to write your answers. So if we have 4 groups of b, 4 times b, b times 4, or 4b are all acceptable ways to write your answer. Multiply h by 6, h times 6, 6 times h, or 6h. Product of 8 and g, So you could have 8g, 8 times g, or g times 8. Any of those would be acceptable answers. And then finally, our last operation is division. So we have 16 crackers that were shared equally between 2 children. How many crackers did each child receive? We'll take 16 and divide it by 2. There were D crackers in a box. The crackers were shared equally between 2 children. How many crackers did each child receive? So another way we can write division is writing it in the form of a fraction. So we'd have D divided by 2. Excuse me. Miss Smith baked Y pies. She gave her neighbor 4 pies. The remaining pies were shared equally among her 3 children. How many pies did each child receive? Well, she baked the Y pies and then she gave her neighbors 4 pies. So which means she had this many pies. She gave 4 away, so we had to subtract. To show that we're doing that section first, it is a good idea to put those in parentheses based on our rules of the orders of operations, where everything in parentheses is done first. And then if we're sharing them equally, we will divide by 3. So if we want to divide 18 by 9, we have 18 divided by 9, or you could write it as 18 over 9. Divide n by 9 would be n divided by 9, or n divided by 9. Divide the product of 7 and n by 5. Well, product tells us to multiply, so one way we could write this is this way. We could also write it this way. We could also write it this way, and other forms of that as well. So there's lots of ways to write this one. One of the reasons why we don't need our parentheses necessarily is that the order of operations, if we're doing both multiplication and division, if you remember, we do work from left to right. So as long as we put the multiplication to the left, division to the right, we do not need parentheses. There's nothing wrong with putting the parentheses in though, just to safeguard. So if we have M cards in a pack and they were shared equally among some children, find the number of cards each child receives in terms of M. So if we have M cards in a pack and we have 4 kids, we're going to divide M by 4. If we have 6 children, we're going to divide M by 6. If we have 8, we're going to divide M by 8. If we have 12, we're going to divide M by 12. And divide N by 7. So that's N divided by 7, or N over 7. And we want to divide the sum of R and 11 by 4. So sum tells us to add, so we will need those parentheses. And we're going to divide by 4. And that's all for today's lesson. As always, I hope this helps.